do a little bit of a recap of what we did last week. Yes, Tinura, that is mixtures part 2. Did you get the printout? දැන් අපි කරන්නේ mixtures එහෙම part 1 part 2 කියලා නැහැ. But මම එහෙම බෙදලා තියෙන්නේ because මේ කොටස අපි hand write කරන්න ඕනේ. But that other part does a lot of theory, so if we like try to hand write, it would take a lot of time. That's why I gave that PDF. Okay, so just to do a little bit of a recap of what we have done in the previous weeks, in grade 10 on the quantification, we have learned the equation N equals M over N. N is number of moles, M is the mass, and capital M is the molar mass, right? When we were learning this in grade 10, I told you we will be using this a lot in grade 11 as well. Then composition, well, we learned a few things now. Mass fraction can be mass of a particular substance divided by the total mass. Volume fraction can be volume of a particular substance divided by the total volume. Mole fraction can be number of moles of a particular substance divided by the total number of moles. Mass over volume can be mass of a particular substance divided by the total volume. And finally, fifth method, concentration, which is moles of a particular substance divided by the total volume. Okay, so that's a bit of a recap. ඒකට තමයි අපි මෙන්න මේ equation එක ඉගෙන ගත්තේ C equals N over V. C කියන්නේ concentration, we use the units moles per cubic decimeter. සමහර වෙලාවට ඒගොල්ලන් කියන්නේ නැහැ concentration එක මේක හැම කියලා. හැබැයි මේ unit එක දීලා තිබ්බොත් ඕගොල්ලන් දන්නවා if this unit is given, that is concentration. N is the number of moles. V is volume, that is cubic decimeter. Sometimes they don't just pollen this is volume kila kiyanne, but they will give something with the unit cubic decimeters or cubic centimeters. Then you know that means it's the volume. Okay. Cannot see anything. Can you see now? Can you see now, Risindi? Let me know. move කරන එක අයින් කරාම තමයි මම හිතන්නේ පේන්නේ. දැන් බලන්න. Now can you see it? Now can you see what I'm writing on the board? Right, okay. Now it's okay, I guess. Okay, I'm giving you another question. Last week, we talked about glucose, sodium hydroxide, and H2SO4. That's my whiteboard. Okay. Liam, yes, that's why. Okay, mass and asked you to find the concentration. Mass. Okay. මේ වගේ තව questions දෙකක් අපි කරනවා and then we will move on to the theory part. Okay, write this question. මම යටින් relative atomic masses ටිකක් දාන්නම්. Sodium is 23, chlorine is 35.5. Okay, based on what we learned in the previous week, quickly do this. How long should I give you for this? 6 minutes? 6 minutes wage mama dennam, but if you need more time, I can give like 2 minutes extra. Okay, make it fast. Make it fast. Amodi, I'm sorry, your message only got loaded now. Nothing much actually. We started the class a bit late. I think when we started, it was a little past 7:15. So as soon as we started, we just did a little bit of a recap of last week, and I asked you all to do this question, the question on the whiteboard. Okay. I'm sorry for the late reply. Have you all finished them? Anybody who needs more time? Anybody who needs more time? Or is everything clear? Please let me know. Did you all finish? If you all finished, give me a thumbs up. Okay, let's see. Chenuli, Desindu, Evindi, Mayumdi, Pamodi, did you all finish? Desindu, Mayumdi? Okay. I'm assuming you're finished, so I will go ahead. Okay. Mama mulima karane kohomada mama mulima karanne. I mean, y'all also can follow the same method. I think that would be easier. Equations the monada kiyanaka wadak na mulima man karanne what is given to me. What are the details that are given to me? Cubic centimeter, 100 cubic centimeters. What is this? Is it a mass? Is it a concentration? Is it a volume? Is it the number of moles? What is it? 100 cubic centimeters, what is it? It's a volume. Cubic centimeters, cubic decimeters, well, then a volume. So 100 cubic centimeters is a volume. And I know I have to convert it to cubic decimeters. So I have to divide by 1000. So I get 0.1 cubic decimeters. Of NaCl solution of concentration 2 moles per cubic decimeter. Itana kelima concentration kila dila tiyanawa. That is 2 moles per cubic decimeter. Back when I was in grade 11, when we were doing this lesson, මම කරේ මෙහෙමයි. මට equations පැටලෙන හින්දා මම කරේ මේ විදිහට ඒකෙන් මට ගොඩාක් ලේසි වුණා. මුලින්ම equations මොනවද මම හිතුවේ නැහැ. මට දීලා තියෙන්නේ මොනවද කියලා බලලා මම ඒ ටික list කරා විතරයි. අහනවා maths එක. maths එක අහනවා. relative atomic masses තියෙනවා කියන්නේ molar mass එක calculate කරන්නත් පුළුවන්. So I'll calculate the molar mass as well. Molar mass, which is symbolized by capital M. Sodium is 23, chlorine is 35.5. So I get the molar mass as 58.5 grams per mole. Make 1000 wali divide kare ai appe volume තියෙන්න ඕනේ cubic decimeters වලින්නේ. Cubic decimeters වලින් but මෙතන දීලා තියෙන්නේ cubic centimeters. In order to convert cubic centimeters to cubic decimeters, I have to divide by 1000. Okay, Cindy? Okay. Now, මොනවද මට තියෙන equations තුන? දෙක. I have n equals m over m and c equals n over v. This was my next step. When I was doing these questions, this was my next step. Volume දීලා තියෙනවා. මම දීලා තියෙනවා mark කරා මගේ rough work paper එකේ. Concentration තියෙනවා. Mass එක අපෙන් අහනවා. molar mass එක තියෙනවා. Number of moles මම දන්නේ. Number of moles උත් දන්නේ නැත්නම් mass උත් දන්නේ නැත්නම් molar mass විතරක් දැනගත්ත කියලා I can't use this equation. එහෙනම් ඒක මම අයින් කරනවා. But this equation I can use, no? Why? Because concentration තියෙනවා, volume තියෙනවා, then I can find the number of moles. Concentration is here, volume is also here, then I can find the number of moles. Concentration is 2 moles per cubic decimeter. Number of moles I don't know. Volume is 0.1 cubic decimeters. So number of moles කියන්නේ මෙයාව මේ පැත්තට ගෙනිච්චාම it becomes multiplication. So 2 times 0.1, I get the number of moles as 0.2 moles. Now I use N equals M over M. Why? Because here, now I have the number of moles already. So number of moles is 0.2 moles. Mass is what they're asking us to find. And molar mass I already calculated here. 58.5 grams per mole. So we'll do a little bit of a simplification. 58.5 multiplied by 2. 0.2, but man 2 ge multiply kala balana. 2 times 5, 10. 2 times 8, 16 plus 1, 17. 1 remaining. 2 times 5, 10 plus 1, 11. The decimal places dekak tibbama I get 11 and M equals 11.7 grams. Did you all get this number? Give me a thumbs up. Is it clear to everybody? Ek may answer kaave natat. Did you all understand this? Okay. Next question. How questions dega copy karna mein wage, okay? This one was question number 5, no, 4, ne? Question number 5. Let me do a little bit of a math. මොකද simplify වෙන්නේ නැතිව දුන්නොත් ඕක අමාරු වෙනවා. 42. Okay. 34.2. හරි මාතක ලියා ගන්න ළමයි. 2 grams of Okay, ළමයි. Quickly do this. 34.2 grams of ගාන හරිනේ 34.2. Yeah, 34.2 grams of sucrose is dissolved in. Now you know the formula of sucrose already, yeah? Is dissolved in 500 cubic centimeters of water. Find the concentration of the sucrose in the solution. Quickly find this. Again, I will set a timer of 7 minutes වගේ තියන්න. මොකද sucrose වල molar mass එක හොයන්නත් ඕනේනේ. Make it fast. You have about 3 more minutes. You have a little less than 1 minute. Make it fast. Okay. Have you all finished? Give me a thumbs up if you have finished. No, it's okay. I will explain anyways. Okay. දැන් මම කියපු මෙතඩ් එකට කරන්න ඕනේ. මොකද මම කියපු මෙතඩ් එක මොනවාද දීලා තියෙන්නේ කියලා බලලා ඒක ලිස්ට් කරනවා. They have given the mass. So mass equals 34.2 grams of sucrose dissolved in 500 cubic centimeters of water. That's the volume. Volume is 500 cubic centimeters. I don't need it in cubic centimeters. I need it in cubic decimeters. So what I got in cubic centimeters, I'm going to divide by 1000. So I get 0.5 cubic decimeters. They're asking us the concentration. Okay. So, බලමු දැන් කොහොමද අපි මේක කරන්න කියලා. Concentration අහන හින්දා කෙලිම මට C equals N over V use කරන්න හිතෙනවා. Volume is given. Okay, great. They're asking us the concentration. Number of moles I don't know. එහෙනම් මට මේ equation එක කෙලින්ම use කරන්න බෑ. එහෙනම් මම මොකක්ද use කරන්නේ? First, I use N equals M over M. This is my first step. Because mass they have given, no. Mass they have given, molar mass I can find. එතරින් මට number of moles ගන්න පුළුවන්. දැන් මුලින්ම මම molar mass එක හොයලා ඉන්නවා. Molar mass of sucrose. What is the chemical formula of sucrose? Yes, what's the chemical formula of sucrose? Yes. All disaccharides have the formula C12H22 and O11. So, අපි මේක multiply කරලා ගන්න ඕනේ. Now, there are එක carbon එකක mass එක 12 and there are 12 such carbons. Plus, එක hydrogen එක mass එක 1 ඒ වගේ there are 22 hydrogens. එක oxygen එක mass එක 16 ඒ වගේ 11 oxygens are there. So 12 times 12 144 plus 22 16 times 16 would be 176. So 6 plus 4 10 10 plus 2 12 1 remaining 4 plus 1 5 6 7 7 7 14 1 remaining 2 3. That is 342 grams per mole. 12 times 12 Na because එක carbon එකක mass එක 12. And how many carbons are there? There are 12 carbons, 12 such carbons. එකක mass එක 12, ඒ වගේ 12 carbons ඉන්නවා. That's why 12 multiplied by 12. Okay, Cindy? Okay, all right. දැන් අපි මේක හොයමු. Now N equals M over M. What is the mass they have given? 34.2. What is the molar mass? 342 grams per mole. So 342 times 1, 342. 342 times 0.1 තමයි 34.2. So the number of moles I get as 0.1 moles. Number of moles is 0.1 moles. Now as a second step, I will go to C equals N over V. Then බලන්න අපිට ලේසි නේද? Because number of moles I have found here, so I have that. Volume I have here, I will add that and I can find the concentration. Number of moles 0.1 mole, we have found it. Volume 0.5 cubic decimeters, we have already found it. I told you we never keep a decimal in the denominator. And now what do? I multiply this by 10 to remove the decimal. If the denominator I have to do the same to the numerator. 0.1 multiplied by 10 is 1. 0.5 multiplied by 10 is 5. So 1 over 5 means, so 1 you have to divide by 5 now. 5 times 0 is 0. It's 10 kya 5 times 2. That would be 0.2 moles per cubic decimeter. Is that clear to all of you? Did you all get this answer? Did you understand it? How is it going? Others? No, one more question. I told you up here the questions thunak karna, right? So we did the NaCl question. Now we're doing, now we just finished sucrose question. We have one more question. No. Questions ahaddi දෙවිදියකට අහන්න පුළුවන්. Actually ඕන විදියකට අහන්න පුළුවන්. මේ if you look at these two equations, method එක කටපාඩම් කරන්න යන්න එපා. අපිට ගොඩක්ම එන්නේ ගොඩක්ම එන්නේ n equals m over m and c equals n over v use කරා. ඒතර දීලා තියෙන ඒවත් එක්ක මොකද්ද use කරන්න පුළුවන් මුලින්ම මොකද්ද ඊට පස්සේ use කරන්න කියලා ඔයා බලන්න ඕනේ. Okay, so that is up to you to decide. ඒක නම් මෙතන they gave volume, concentration and they asked the mass. So I use c equals n over v equation first, n equals m over m equation second. I දීලා තියෙන dataත් එක්ක මොකද්ද මට මුලින්ම use කරන්න පුළුවන් equation එක. මෙතන concentration and volume එක දීලා තිබ්බින්ද මම මුලින්ම මේ equation එක use කරා. ඒකේ number of moles හොයාගත්තා. Then I have number of moles, here I have the molar mass. ඒකේ මම mass එක හොයාගත්තා. මෙතන දීලා තියෙන dataත් එක්ක මට මුලින්ම c equals n over v හොයන්න බෑ. එහෙනම් මම මුලින්ම use කරන්නේ n equals m over m. Because mass උත් තියෙනවා, molar mass උත් තියෙනවා, I just have to find the number of moles. Sorry. Then as a second step only I use this. මොකද දැන් moles ගන්න හොයාගත්ත volume තියෙනවා, then I can find the concentration. So දීලා තියෙන dataත් එක්ක දැන් මම මුලින්ම concentration හොයන්න ගියොත් මට කරන්න බෑ. I number of moles මෙතන දීලා නැහැනේ, only volume is given. ඕනිම equation එකක් simplify කරන්න එක unknown term එකයි තියෙන්න පුළුවන්. Let's say for an example c equals n over v හොයද්දී, let's say you have volume but you don't have number of moles, then you can't find concentration, right? But let's say you have number of moles and you have volume, then you can find concentration, right? Unknown terms එකයි තියෙන්න පුළුවන්. ඒතර ඒක හොයන්න පුළුවන් අනිත් values ටික තියෙනවා නම්. Let's do another question like this. මේක last question එක අපි මෙතන කරන, but මේ වගේ චුටක් similar question එකක් අපි ඉස්සරහට ආයෙත් තව පාරක් try කරනවා. Let's do මතකම ලියන්න. Sorry, a mistake. Let's say 5. Urea wala chemical formula එක මම දෙන්නම් because that is not something you know. So I will give it. Carbon, oxygen, bracket, nitrogen, 2 hydrogens, bracket 2. Nitrogen 14, hydrogen 1. Okay, quickly do this. මේකත් මම 7 minutes වගේ දෙන්නම්. But for this, I don't mind giving an additional minute. Let's see how you can do within 7 minutes. Okay, start. Quickly start, Lamaya. Give me a second. Now you and have 1.5 more minutes. We'll discuss. But මාත් මේ ගාන හැදුවේ නැහැ, but we'll discuss. Probably. 2.5 කීයද volume එක 500 no. So 5 I think so. We'll see. Yeah. Okay. Yeah. Okay. So again, as usual, we first try to figure out what is given to us. 2.5 moles per cubic decimeter is the concentration. Tinur and Desidu, I think your answers are correct. Huh? But anyways, we'll discuss. 2.5 moles per cubic decimeter. Then volume is 500 cubic centimeters. 500 cubic centimeters you divide by 1000 to get it in decimeters, cubic decimeters. Then you get 500 divided by 1000 is 0.5 cubic decimeters. Then අපිට n equals අපෙන් අහන්නේ මොකද්ද? mass එකනේ. They asking us the mass. Mass තියෙන equation එක n equals m over m. මට molar mass එක නම් මෙතනින් calculate කරගන්න පුළුවන්. හැබැයි මම number of moles දන්නේ නැහනේ. Just with the molar mass without even knowing the number of moles මට mass calculate කරන්න බෑ. Number of moles දන්නේ නැහනේ. දෙකක් තිබ්බොත් එකක් හොයන්න පුළුවන්. But එකක් තිබිලා මේ දෙකම දන්නේ නැත්නම් I can't find mass, right? And a equation use kind of bad. But C equals n over V, I can use Y. Volume තියනවා, concentration තියනවා, then I can find the number of moles. And that is what I'm going to use. Concentration is 2.5 moles per cubic decimeter. Number of moles I don't know. Volume is 0.5 cubic decimeter. Then 0.5 may petra arangana. N equals 2.5 multiplied by 0.5. 25 times 5 is 125. Decimal places metan ekai. So I have to keep 2 decimal places. I'm going to write 1.25 moles. 1.25 moles. Now I will go to n equals m over m. Then why? Now I have the number of moles here. Molar mass I can calculate from here. First of all, we'll calculate the molar mass. Calculate molar mass of urea. There is 1 carbon, so carbon is 12. Plus, there is 1 oxygen and oxygen is 60. there is one nitrogen here. හැබැයි අව 2 ගේ multiply වෙනවා. So 1 times 2, there are 2 nitrogens here. එක nitrogen එකක් 14, එහෙනම් 2 nitrogens කියන්නේ 14 times 2. Plus, there are 2 hydrogens here. ඒ වගේ දෙකක් තියෙනවා. ඒ කියන්නේ 2 times 2, 4 hydrogens. 1 hydrogen is 1, so 4 hydrogens would be 1 times 4. So 12 plus 16, 14 times 2 is 28, 1 times 4 is 4. So 10, 20, 2 remaining, 4, 5, 6, 60 grams per mole is a molar mass of urea. Now I will calculate the mass. Number of moles is 1.25 moles. Mass, I don't know. Molar mass is 60 grams per mole. Make a multiplication. Mass is equal to 60 times 1.25. We'll see. 1.25 multiplied by 60. 0 ka ayin kalama 6 vitarak danna 6. 6 times 5 is 33 remaining. 6 times 2 is 12. 13, 14, 15. 1 remaining. 6 times 1 is 6 plus 1, 7. මෙතන එක 0 එකක් මම ලියන්න නැතුව තිබ්බනේ. ඒ 0 එකත් මම මෙතනට දානවා. Here there are 2 decimal places, so I'm going to keep 2 decimal places. So yes, I get the answer as 75 grams. Is it clear to all of you, Lamai? Give me a thumbs up if it's clear. Others? Okay. Then I think we are good to move on with the lesson. Give me a second. ගන්න බාන mixtures part 2 note එක ළමයි. අපි concentration කරා. Okay. Take mixtures part 2 note. So up to this point, what have we been doing? අපි mixtures වල කතා කරා. There are 2 types of mixtures, as homogeneous mixtures and heterogeneous mixtures. Then we talked about the differences of them. Then we talked about how to express whether it's heterogeneous or homogeneous along with the physical state, like solid, solid, homogeneous, solid, liquid, heterogeneous, liquid, liquid, homogeneous, liquid, gas, heterogeneous, and likewise. Then we talked about what a solute is and what a solvent is. Then we talked about what solubility means. Then we talked about the factors affecting solubility. Under that, we talked about temperature, nature of solute, and nature of solvent. Then we talked about different types of solutes and solvents and how the concept of like dissolves like. ඊට පස්සේ we talked about solubility of a gas, and then we moved on to composition of a mixture. Under that, we talked about mass fraction, volume fraction, mole fraction, mass over volume, and moles over volume. Moles over volume තමයි concentration කියලා කියන්නේ. So up to that point, we have learned. So today we are going to move on to our part 2 of the lesson. Mihaly, your first day was last week, ned?
Yes, teacher.
Right, that's why. Okay, I'll send it again. For today, I will screen share, so you like look at the note from the screen, and whatever extra I give you, you write it on a separate piece of paper, and then later get the printout and copy them down. Okay?
Okay, miss. Thank you.
Okay. Otherwise I might forget. Okay. All right, let me get the note to the whiteboard. Okay. Mixtures part 2. Preparation of standard solutions. First of all, we need to know what exactly are standard solutions, right? What is a standard solution? This is a solution in which the concentration is very accurately known. Standard solutions වල ළමයි අපි concentration එක accurately දානවා, right? ඒ කියන්නේ for an example, let's say you're given like a transparent liquid and they say this is hydrochloric acid. Hydrochloric acid is actually a transparent liquid. නිකම්ම hydrochloric acid එකක් දෙනවාට bottle එකක දාලා. ඔයාට එකෙන් ඇත්තටම වැඩක් ගන්න බෑ unless you know the concentration. Because knowing the concentration is very important. ඔයා ඒ hydrochloric වලින් මොන වැඩේ කරන්න ගියත්, I mean, because I have been working in labs for so long. So personally, I also know that concentration නැති liquid එකකින් වැඩක් කරන්න හරි අමාරුයි. අමාරු කියන්නේ වැඩක් කරන්න බෑ. එහෙම වුණොත් අපි ඒකේ concentration එක වෙනම හොයාගන්න ඕනේ. Okay. So it is very important that we know the concentration of any solution that is given. So නිකම් HCl එකක්, let's say මම ඕගලන්ට දෙනවා නිකම් HCl solution එකක්. Let's say චෙනුලි ඕගලන්ට දෙනවා HCl solution එකක් of concentration 2 moles per cubic decimeter. Which one would be better for you to use? The one that Chinuli gives you. Because it has a concentration that is accurately given. මම නිකම්ම solution එකක් දුන්නාට labs වල එහෙම වැඩ කරන්න බෑ. So a standard solution is a solution where the concentration is very accurately known. මේ unit conversion එක මම already කතා කරලා නේද තියෙන්නේ? We learned about a unit conversion, right? Cubic decimeter, cubic centimeter situation. Did we write a note? Yeah, no, okay, all right. ඒකද මම මේක ආයෙමත් කතා කරන්න යන්නේ නැහැ. We talked about all of this last week. හරි. දැන් මේ lesson එක අපි මොකද්ද කරන්න හදන්නේ? We are going to prepare a standard solution. කියන්නේ concentration එක හරියටම තියෙන solution එක අපි prepare කරන්න හදන්න. So I don't know, at your school they might do it physically in the lab. හැබැයි මම දන්නවා ගොඩක් ඉස්කෝලවල lab එකේ කරන්නේ නැහැ කියලා. Back when I was doing O levels, I did O levels actually in 2016. මේ අලුත් syllabus batch එකේ I wrote O levels as the first batch. So that's why, I mean, I learned this syllabus and then I taught this syllabus for like 6 years. So that's why I'm very familiar with the syllabus, right? එතකොට අපේ ස්කෝලේ we did this in the lab. If I remember right, we prepared a standard solution. Yeah, we prepared a standard solution in the lab. එක කරන විදිය හරියටම කියා දුන්නා. Some of your schools they might actually show it, but most of the schools I know they won't do it in the lab. ඒක හින්දා අපි මේක කරද්දි මට අපිට physically මේක කරන්න විදියක් නැහැනේ. So the best way to do this is, for us practically, is that we will kind of envision මේක මෙහෙමයි කරන්නේ මේක මෙහෙමයි කරන්නේ කියලා ඔයගොල්ලන් imagine කරන්න මම කියද්දි. Okay, I will tell you in a way so that it's easier for you to imagine. Okay, first of all we will see what are the equipment we need to prepare standard solutions. Number 1, we need volumetric flasks. May picture ka nang it's clear na, but let me just get a picture from Google and show you. Oganda or tarang Google kalla picture ka you can, I mean, obviously you can get pictures from Google, right? But I will show you one on the picture ka may picture ka tamay mang hitanne thiyenne in that note. I will zoom it and get like a proper, and I will show you another picture. This is another volumetric flask. Fine, bane. ළමයි. ඒ ඔයගලන් S දෙකෙන් දකින්න එක තමයි හොඳම. Please ignore what's on the board. I will explain. So these are some images of volumetric flasks. So let me organize them here so that I can show them to you separately. Volumetric flask එකක් කියන්නේ ළමයි. There is a definitive volume. For an example, if you look at these volumetric flasks, there are different ones. මේකම තමයි ඔයාලගේ note එකේ, but it's very small. That's why I took this larger picture. මෙන්න මෙහෙම එක mark එකක් තියෙනවා. Right? And volume එකක් මෙහෙම mention කරලා තියෙනවා. මේකේ ගහලා තියෙන volume එක කීයද? 100 milliliters. Sorry, 1000 milliliters. That means 1 liter. What this means is that in this 1000 milliliter volumetric flask, there's a mark here, no? Or may mark එකට වෙනකන් මොකක් හරි liquid එකක් fill කරොත්, that is 100 milliliters. Sorry, 1000 milliliters. Then there's a 500 milliliter volumetric flask as well. එතනත් මෙහෙම mark එකක් තියෙනවා. If you fill the solution up to that mark, that means that is 500 milliliters. Then there's a 250 milliliter volumetric flask. Again, mark එකක් තියෙනවා. If you fill up to that mark, there will be 250 milliliters of solution. Then there's a 100 milliliter volumetric flask. There's a mark again where a mark eකට fill කරොත්, that is 100 milliliters of solution. Then there's a 50 milliliter one, ඊළඟ මෙතන 25 milliliter one, then here this is a 10 milliliter one. මම personally 10 milliliter එකක් නම් use කරලා නැහැ එච්චර පොඩි ඒවට, but everything else I have used, right? So 25 milliliter කියන්නේ ගොඩක් පොඩි එකක්, 100 milliliters කියන්නේ ලොකු එකක්. Sorry, 1000 milliliters, which is 1 liter. So again, එක ranges වල volumetric flasks තියෙනවා. Depending on the volume of the solution that you need to prepare, you have to select the volumetric flask. If you need to prepare just 500 cubic centimeters, or මෙයාව තමයි ගන්න. If you need to prepare 100 cubic centimeters or 100 milliliters, you have to get this. If you need to prepare 1 cubic decimeter, which means 1000 cubic centimeters, you have to get this. Likewise, depending on the volume that you have to prepare, you can pick a volumetric flask. All volumetric flasks come with a lid. Lid එක 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 විදියට එනවා. දැන් modern lid එක නම් අර අරින වහන lid එකක් එන්නේ. පරණ volumetric flask වල ඊට වඩා ලස්සන lid එකක් තියෙනවා, right? So all of them come with a lid. මොකද මේ solutions ඔක්කොම වහලා තියන්න ඕනේ. නැත්නම් impurities එහෙම ඇතුළට යනවනේ. So they have to be properly sealed. And this is another volumetric flask. Now this is a 250 milliliter volumetric flask. බලන්න එතන මෙන්න මෙතන තමයි mark එක තියෙන්නේ. So here the solution is filled up to the mark. මේ mark එකට වෙනකන් solution එක fill කරලා තියෙන්නේ. That means there is 250 milliliters of the solution. මේ බලන්න මෙන්න මේ වගේ lid එකක් තමයි පරණ කියන්නේ ගොඩක් පරණ නෙවෙයි. But ගොඩක් අපේ labs වල නම් තියෙන මෙන්න මේ වගේ lid එකක් තියෙන volumetric flask එකක්. This is also another volumetric flask, 200 milliliters. මේකේ lid එක පේනවද දන්නේ නැහැ ඔයගලන්ට. I can't even see whether there's a lid there. Then this is also another volumetric flask. මේ තියෙන mark එක. Here there's a white color mark. See. මේකේ lid එක මෙතන පෙන්නන්නේ නැහැ, but always volumetric flasks come with a lid. So those are volumetric flasks, and volumetric flasks are always glass. They are always glass equipment. Glass වලින් තමයි ඔක්කොම volumetric flasks හදලා තියෙන්නේ. Okay. Then let's move on to our next part. What is equipment needed to prepare standard solutions? Number 1, volumetric flask. Number 2, watch glass. Watch glass කියන්නේ ළමයි මෙන්න මේ වගේ glass එකක්. It's kind of curved and it's just like just a circular glass. Circular නිකන් plate එකක් වගේ පොඩි glass එකක්. It's kind of curved. So that's called a watch glass. Then we have a funnel. This is a funnel. This is also glass. Wash glass is also glass. Then we have a wash bottle. Wash bottle එක කියන්නේ මෙන්න මෙහෙම එකනේ. It is actually not glass lamai. This is made of plastic, right? Plastic එකක් තියෙනවා මෙන්න මෙහෙම කෑල්ලක් තියෙනවා. එතකොට what happens is that something like this. Is my video on? Yeah. So මේක නම් මේ වෙන bottle එකක්, but let's close this otherwise water will spill away. මෙන්න මේ වගේ නෙවෙයි, but as the picture shows, what I want to show you is that a bottle එක මෙහෙම squeeze කරාම අර button through that tube water comes out. So at chuttak squeeze karot, a little bit of water will come out. If you squeeze a lot of water will come out. Likewise, you can control how much water comes through the tube in the wash bottle by squeezing the bottle however much you need. So that is wash bottle. මෙතන ළමයි මතක තියාගන්න, in the exam they ask you what are the glass equipment you need to prepare standard solution. If they ask you the glass equipment, what a wash bottle එක ලියන්න බෑ. Because wash bottle is not glass, it is actually plastic. But volumetric flask, watch glass, funnel, these three are glass. So if they in the exam, if නෙවෙයි ගොඩක් past papers අපි කරනවානේ, in July we are going to start past papers. When we are doing past papers, you will see that they ask you what are the glass equipment you need to prepare standard solutions. Then you can only write volumetric flask, watch glass, and funnel. Okay. Okay. Then අපි මොකද කරන්න හදන්නේ? We are going to prepare 500 cubic centimeters of 1 moles per cubic decimeter sodium chloride solution. 500 cubic centimeters of 1 moles per cubic decimeter sodium chloride solution. Now, අපි ගන්න හදන විදිහ දන්නවනේ already නේ. Now this is the volume. මේක already calculation එක කරලා තියෙන්නේ. Now when we are making a standard solution, this is the step 1. First step එක මොකද්ද? කොච්චරක් mass එක ඕනේද කියලා. So first of all, now volume is 500 cubic centimeters. When you divide it by 1000, you get that is 0.5 cubic decimeters. This is concentration. Then lamai, concentration equals number of moles divided by volume. Concentration they have given, volume they have given, so you can calculate the number of moles. So hemata meta number of moles calculate kala tiyenne. C is concentration, N number of moles is N, volume is V. So එතකොට මෙතන N ඇවිල්ලා තියෙනවා 0.5 moles. If now sodium chloride is salt, right? අපේ ගෙදර තියෙන salt use කරන්න බෑ. මොකද usually table salt has some iodine mixed with sodium chloride. But in the lab there is pure sodium chloride. මම උගලන්ට කිව්වොත් measure 0.5 moles of sodium chloride කියලා. Can you measure 0.5 moles of sodium chloride? Can you measure? ඔගලන් හිතනවාද lab එකේ scale එකක් තියෙනවා කියලා moles measure කරන්න? Is there a scale? Do you think there's a scale in the lab to measure the number of moles? No. Moles measure කරන්න scale එකක් lab එකේ නැහැ. අපි කොයි වෙලෙවත් moles හොයාගත්තා කියලා, we have no point because we can't actually measure moles. What we can actually measure is mass. එහෙනම් moles mass වලට convert කරගන්න අපි use කරනවා N equals M over M equation එක. දැන් sodium chloride වල molar mass එක අපිට calculate කරගන්න පුළුවන් නේ. ඒකෙන් so molar mass I have, number of moles I have, from that I can find the mass. So the mass I need is 29.25. Now can I measure 29.25 from a scale in the lab? 29.25 මට measure කරන්න පුළුවන්ද? Yeah. 29.25 is a mass that I can measure. So there are multiple scales that you can use to measure mass in the lab. Okay, let's go to the next page. So whenever you are asked to prepare a standard solution with a certain volume, ඔයා මුලින්ම බලන්න ඕනේ මම එහෙනම් මේ standard solution එක create කරන්න what is the mass of sodium chloride I need. And that mass or calculation එකකින් හදාගන්න. That is step number 1. Okay, step number 1. Then step number 2. Now I already got the mass as 29.25. I'm going to weigh 29.25 grams of sodium chloride very accurately onto a watch glass using a 4-beam balance or chemical balance. 4-beam balance එකක් කියලා කියන්නේ ළමයි අර නිකන් කඩේ තියෙන ස්කේල් එකක් මෙම් තරාදිය දැන් කඩවල ඉස්සර ග්‍රොසරි කඩවල තිබ්බ තරාදියක්. ඒ තරාදිය වගේ තමයි හැබැයි ඒ විදිහටම නෙවෙයි තියෙන්නේ. අපිට පුළුවන් මේ එක ගොඩක් what do you call it? There are like 4 different levers that we can adjust. By adjusting that, we can measure the mass. You don't need to know the exact technique behind that. But by adjusting different levers, we can get whatever the mass we want. Habay then 4-beam balance because now actually in the labs, we very rarely use 4-beam balance. Now we use a digital balance. So much easier, no? You can get the reading very accurately using the digital balance. So what do? We are going to weigh the mass that we calculated here, 29.25 grams of sodium chloride very accurately. Can't accurately measure karaganwa onto a watch glass using a balance. So now this is my watch glass. Now I'm going to imagine karaganna. So watch glass again, up a glass. So sodium chloride is a powder. So sodium chloride 29.25 I'm measure karaganna. 29.25 is a very small amount, no? So make 29.25 grams of sodium chloride onto a watch glass. Let's go to the next step and see. Step number 3. බලන්න ළමයි මෙතන අපි prepare කරන්න ඕනේ volume එක 500 cubic centimeters නේ. The volume that they want you to prepare is 500 cubic centimeters. Then what kind of a volumetric flask should I choose? What should be the volume of the volumetric flask you choose? Yeah, 500 cubic centimeter or 500 milliliter volumetric flask. දීලා තියෙන volume එකට අදාළ volumetric flask එක select කරනවා. They're asking you to find 500 cubic centimeters. අපේ volumetric flask වල බලන්න මෙතන තියෙනවා. See, this is the 500 milliliter one. You can get this one. Okay. Okay, let's move back here. So since I want to prepare 500 cubic centimeters, I'm going to select a 500 cubic centimeter volumetric flask. Remove its stopper. Stopper can a lid decker. So I'm going to remove the lid. And I'm going to keep a clean funnel. On a bar nega karna vidya. So this is my funnel. Sorry, this is my volumetric flask. I'll try to draw it as best as I can. Something like this. This is 500 milliliters. And එතන මෙන්න මෙහෙම mark එක තියෙනවා. So ඒකට මෙහෙම lid එකක් set කරලා තියෙනවා. This is the stopper. Kind of like a lid. So this is the lid. So what do? I remove the stopper. Mama lid එක remove කරනවා. I'm sorry, Lamai. My internet Wi-Fi got switched off. So let me. Can you all hear me? Okay. Hari. Here, no? For those of you who cannot see the whiteboard, I will send the link of the whiteboard in the main chat. Okay, so as I was saying, we need to prepare 500 cubic centimeters. So I chose a volumetric flask of volume 500 milliliters or 500 cubic centimeters. But among a volumetric flask, what I do is I remove its stopper. Stopper එක කියලා කියන්නේ ළමයි lid එක. So මම lid එක අයින් කරනවා. I'm going to funnel. So I'm going to keep a clean funnel now. Remember, we also wanted a funnel. A funnel like a place kara. We are going step by. Okay. Then step number 4. Step number 4. Transfer the weighed sodium chloride. Transfer the weighed sodium watch glass to the volumetric funnel using the wash bottle. Properly wash the watch glass and inner surface of the funnel. We have to make sure all sodium chloride is transferred into the volumetric flask. අපේ මේ volumetric flask එකේ තියෙනවනේ අපි measure කරගත්ත sodium chloride ටික. So I'm going to bring this volumetric funnel and I'm going to slant it a bit like this. ඊළඟට මම මොකද කරන්නේ මගේ wash bottle එක ගන්න. I take my wash bottle. Something like this now. මෙහෙමනේ තියෙන්නේ. මම මේකෙන් water spray කර කර මේකේ තියෙන වේ කරගත්ත sodium chloride ටික මේකට transfer කරගන්න. Okay, like this. එහෙම water spray කර කර all the sodium chloride I'm going to transfer into the volumetric flask through the funnel. So all the sodium chloride that I measured will be transferred through the funnel to the volumetric flask. Like this. Okay. Then සමහර වෙලාවට ළමයි even when you measure sodium chloride මේ watch glass එක වටේ තැන තැන තියෙන්න පුළුවන් කුඩු කුඩු because it's a powder no? A powder like a very tiny particle size, right? So watch glass එකේ තැන තැන තියෙන්න පුළුවන් වටේ. I mean all the sodium chloride you transfer into the volumetric flask, but there could be like a few tiny little pieces left all over. So you wash all over it thoroughly. And wash කරද්දී මේ ඔක්කොම funnel එකෙන් වැටෙන විදිහට wash කරන්න යා. So වතුරත් එක්කම තමයි transfer කරන්නේ. ඊට පස්සේ funnel එක වටේ තියෙන පුළුවන් කුඩු powder could be left on the funnel also. So you wash all around the funnel also very well. Up to that point, is it clear? Thumbs up, everybody. Desindu, Evindi, Mayumdi, Miheli, Pamodi. Pamodi? Let me make sure you request the recording because you joined a bit late. Then the material continue karagena Anna. We started mixtures part 2, that PDF. So now we are learning the steps to prepare a standard solution. Okay.
Okay, teacher. I'm sorry for the.
Okay, no worries. WhatsApp එකේ දාලා තියෙන recording කිල්ලලා. So that is what I do here. Then let's see what happens next. Step number 4. Step number 4. Add about 2/3 of the required volume of water. දැන් මෙතන මම wash bottle එකෙන් wash කර කර ඉද්දි කොහොමත් water ටිකක් ඇතුළට යනවනේ නේ. A certain amount of water will have already like entered into the volumetric flask, right? මම මේක 2/3 වෙන විදිහට volume water දානවා දැන් wash bottle එකේ. So now I can remove the watch glass. Now I can remove the watch glass and මම දැන් මේ funnel එකෙන් water දානවා 2/3 වගේ වෙන විදිහට. මෙන්න මෙච්චරක් වගේ වෙන විදිහට. දාලා මම මොකද කරන්නේ? Let's see. Now what do I do next? Stopper the volumetric flask. Add 2/3 of the required volume of water. Stopper the volumetric flask. I'm sorry, Lamai. I was on mute neither. Where did I stop? Okay. Add about 2/3 of the required volume. අපිට ඕන volume එකෙන් 2/3 විතර දාලා අපි stopper එක ගන්නවා. That means we remove the wash bottle, we remove the funnel and we put the lid back on. And we shake the flask to dissolve all the sodium chloride there. මේකට දාලා තියෙන sodium chloride එක dissolve වෙන්න මම හොඳට මෙයාව shake කරනවා. I shake it. So there are different ways to mix it actually. දැන් ඔයා නිකන් මෙහෙම ඕන විදිහට shake කරන්න නැත්නම් මේ lid එක වීසි වෙලා යනවා. So this is like I'm talking with experience in the lab. සමහර කට්ටිය මෙහෙම shake කරනවා lid එක වීසි වෙලා යනවා. ඒතර ඔක්කොම liquid එක හැමතැනම spill වෙනවා. Sometimes they shake. Now volumetric flask is a glass bottle, right? So when you shake ඒක මෙහෙම අතෙන් ලිස්සලා ගිහලා glass එක කුඩු වෙනවා වීසි වෙනවා. Sometimes it could be like a strong acid, right? ඒකයි ඇඟවල වැටුනොත් මේක හොඳ නැහැ. So shake කරන විදියක් තියෙන එක්ක මෙහෙම neck එකෙන් neck එක කියන්නේ මෙන්න මේ හරියට. මෙන්න මේ හරියෙන් වගේ you hold it and you mix it well like this. මෙහෙම වටේට කරකවනවා. or මෙහෙම lid එක උඩ අත තියාගෙන මෙහෙම shake කරනවා. So you hold the lid like this and you shake like this. So somehow you make sure that all sodium chloride is mixed. එතකොට it would look something like this. දැන් ඔක්කොම sodium chloride එක mix වෙලා. Delete this. I'm sorry, wait. Okay. So now all the sodium chloride is properly mixed. Now you can't see any sodium chloride in this solution because all the sodium chloride will be mixed and now there's only water. Up to that point, is it clear? Am I? Thumbs up? Okay, so I have a question. Why can't we add NaCl directly without water and add water later? ඒ කියන්නේ watch glass එකේ තියෙන NaCl ටික directly අය අපිට volumetric flask එකට දාන්න බැරි. Good question. So there's a major reason why we cannot do that, right? ඒ කියන්නේ හිතන්න now. So this is my volumetric flask, let's say, and I keep a funnel here. And my watch glass එකේ තියෙන ටික මෙහෙම හලනවා. Now sodium chloride is a powder. What do you think will happen if you just hold the watch glass like this and put everything, like shake everything into the funnel? හැමතැනම විසි වෙනවා. And also even in a lab there will be at least a little bit of wind. හරි මොනා හරි තියෙන පන මම හයියෙන් හුස්ම ගත්තත් like if I breathe out like that, some of the particles can fly away. Remember, our mass is 29.25. Podi powder particle එකක් ගියත් මේකේ decimals ගන්න it could be 29.24. We have to be very careful. හැබැයි watch glass එක කෙලින්ම හලන්න නැතුව watch glass එක චුට්ටක් slant කරලා අල්ලලා මම wash bottle එකෙන් wash කර දාද්දි water එකනේ යන්නේ. So wash bottle එක squeeze කරාම water මුලින්ම watch glass එකට වැටෙනවා. Because of the water, the sodium chloride will become moist. Dry විදිහට තියෙද්දී හැමතැනම fly වෙන්න පුළුවන්. Because like if it's like in the powder form, but when you wash it with a watch glass, there's a higher chance for all the sodium chloride to transfer into the volumetric flask. Water නැතුව නිකම්ම හැලුවොත් එකක් තමයි watch glass එකේ හැමතැනම ඉතුරු වෙනවා, flask එකේ මේ funnel එකේ හැමතැනම ඉතුරු වෙන්න පුළුවන් චූටි particles that we can't even see can remain on the watch glass as well as the funnel. And also, while we are transferring, some of the powder particles that sometimes we can't even see could fly away. It could be the wind, it could be a fan, it could be my breathing, it could be someone else's breathing. These factors could affect, and some powder particles can fly away. So that's not very good because the decimal points can change in the mass. මේ decimal point එකක් හරි වෙනස් වෙනවා කියන්නේ number of moles වෙනස් වෙනවා. Number of moles වෙනස් වෙනවා කියන්නේ concentration උත් වෙනස් වෙනවා. Then it is not a standard solution. Is it clear, Mayundi? Okay. Then මොකද කරේ? Where did we stop? අපි shake කරලා ඔක්කොම sodium chloride එක mix කරානේ. Step number 6. After all sodium chloride is well dissolved, add water slowly by keeping the eye meniscus at the level mark on the volumetric flask. Then මොකද කරන්නේ? Again, I'm going to remove the stopper. And I'm going to take my wash bottle. And I'm going to squeeze water very slowly until I fill water to this. My wash bottle එකෙන් water add කරනවා until all water is filled. පොඩි පොඩි දාන්න ළමයා. Little by little until I fill up to this mark. මේ mark එක ගාවට fill කරද්දි ළමයි එකක් තමයි you have to now you know when you fill any liquid to a small tube. පොඩි tube එකකට liquid fill කරද්දි මෙහෙම පොඩි curve එකක් එක්ක නේද fill වෙන්නේ. මෙහෙම straight fill වෙන්නේ නැහනේ. සාමාන්‍ය මේ වගේ tube එකකට water හරි any liquid when you fill it, it doesn't feel like a straight line. There's like a very slight curve. Have you noticed that? පොඩි මෙහෙම curve එකක් තියෙනවා කියලා have you noticed that? Yes or no? Yes, now give me a thumbs up. I'll try to show you a picture as well. I'll try to show a picture. Something. This is a good one. හරි මම මුලින් explain කළා ඔයගොල්ලෝ picture එක පෙන්නන්න. එතකොට මේකට water fill කරද්දී මේ පොඩි curve එක හැදෙනවනේ. ඒ curve එකේ the bottom part of the curve should be on the mark. මේ volumetric flask එකේ mark කරලා තියෙනවනේ මෙහෙම ඉරක්. මම ඒ ඉර අඳින්නම් black වලින්. So when I fill water, that little curve, the bottom part of the curve should be on the mark. Right, bottom part of the curve should be on the mark. And also, when you're filling, when you're filling, you have to make sure that you are looking at this at the eye level. මෙන්න මේ eye level එකේ මෙහෙම බලන්න ඕනේ. උඩින් බැලුවොත් ඔයා වැරදි විදිහට fill කරන්න. යටින් බැලුවොත් ඔයා වැරදි විදිහට fill කරන්න. So your eye level has to be at the same level as the calibration mark on the volumetric flask. Volumetric flask එකේ තියෙන mark එකට ඔයාගේ eye level එක adjust වෙන්න ඕනේ. And when you fill the water, the bottom part of the curve should be on the mark. I will show you a picture that properly shows this quite well. බලන්න මෙන්න මේ picture එක. මේ picture එකේ මෙන්න මේ ලාවට line එකක් තියෙන මෙතන. That is the mark of the volumetric flask. Okay? එතකොට බලන්න මෙතන liquid එක fill කරලා තියෙන කොහමද? මේ curve එකේ bottom part එක තමයි mark එකට හිටින්නේ. Is this clear ළමයි? Thumbs up please. මේක තේරුණා කියලා. දෙසිඳු එවින්දි මයුම්දි පමෝදි රිසින්දි තිනුර එවින්දි මයුම්දි පමෝදි එවින්දි and pamodi, is it clear? Let me know. So this is the calibration mark and mage liquid level එකේ bottom part එක තමයි ඒ mark එකට හිටින්න ඕන. That is called the meniscus. අනිත් එක තමයි, as I told you before, it has to be at the eye level. Like this. මෙන්න මේ වගේ eye level එකෙන් තමයි බලන්න ඕනේ. This is exactly what I told you. Your eye level has to be on the same level as the liquid. මේ මුඩින් බැලුවොත් ඔයාට වැරදි. කියන්නේ ඔයාට වැඩිපුර ෆිල් වෙනවා. Right? මේ බාන මේ මාක් එකට ගානට ෆිල් කරන්න පුළුවන් if you have the eye level on the meniscus. But if you look at it from above, ඔයා මාක් එකට වඩා වැඩියෙන් ෆිල් කරනවා. එතකොට it's not accurate. ඔයා පල්ලෙහා ඉඳන් බැලුවොත් ඔයා මාක් එකට වඩා අඩුවෙන් තමයි ෆිල් කරන්නේ. That is also not accurate. So your eye level has to be on the same level as the meniscus. Okay. ඊළඟට step 4. Sorry, step 7. Stopper the volumetric flask and mix everything well. දැන් මෙතනට water fill කරාට පස්සේ මොකද මම කරන්නේ? මම ආයෙමත් lid එක දාලා මේක close කරනවා. Close කරලා again I shake it well and make sure everything is well mixed. And now I have my standard solution. Now this is my standard solution. Okay? This is my standard solution. So, what are the factors to consider when preparing standard solutions? Balamu. We have to clean all the equipment properly. Now, we prepared NaCl, sodium chloride standard solution. Hitanna, if there's an impurity in the volumetric flask or the funnel or the watch glass, කොහේ හරි impurity එකක් මොන හරි වෙන දෙයක් තිබ්බොත් එහෙම එයාවත් මේක ඇතුළට යනවා. Then I don't have pure sodium chloride, I will have other substances as well. එහෙම වෙන්න බෑ. My equipment has to be very clean. Weigh the solute accurately. When I measure now, in this particular case, I have to measure 29.25 grams of NaCl. So, එක හරියටම point එකටම measure කරන්න ඕනේ. Wash the solute on the watch glass and the funnel and transfer properly. Watch glass එකේ ටික මම wash කරලා through the funnel I put it into the volumetric flask now. I have to make sure there is nothing remaining on the watch glass. All the little particles I have to make sure I wash and transfer into the volumetric flask. Then in the funnel also, I have to wash the funnel very well. Funnel එක වටේ ඉතුරු වෙන්නත් පුළුවන්. So all of that I have to wash into the volumetric flask. Use the correct technique for mixing, as I said. If you like carelessly mix, the lid could fly away, the volumetric flask could fly away, the glass could crack. If it's like a very sensitive solution, කාගරි ඇඟේ වැදුනොත් එහෙම skin problems එන්න පුළුවන්, burn වෙන්න පුළුවන්, especially strong acids. ඒ වගේ ගොඩක් ප්‍රශ්න වෙන්න පුළුවන්. ආයේ මුළු standard solution එකම you have to make it from the beginning again. So ඒකින්ද අපි correctly mix කරන්න ඕනේ. Adjust the final volume carefully. As I said, eye level එක meniscus එකට තියලා ගානට fill කරන්න ඕනේ. Prevent the entry of impurities. Once you make the standard solution, you have to make sure that you always keep the lid on. හැමලෙම lid එක on එකේ තියන්න ඕනේ. Otherwise, impurities can dust or whatever could go inside the solution. That's not good. Is that clear, Amai? Is it clear? Again, thumbs up. මේක අර practically කරන්න බැරි හින්දා මම ඔයගලන්ගෙන් අහන්නේ හැමලේම, so that I kind of want you to imagine. That's why I like try to animate as much as I can. Okay, I have a question. Do you have space in the note to write? පල්ලෙ පොඩක් ඉඩ තියනව නේද? I have two questions actually. My question number 1. Q1 කියලා දාලා යන්න. A student was supposed to make a glucose solution of one. එතනට නැත්තම් ළමයි ඔයගන්ට notebook එකේ ලියන්න පුළුවන් මේ question එක. 1 moles per cubic decimeter. However, after making the standard solution, the concentration of the standard solution was measured to be less than the actual concentration needed. What are the possible errors that has happened? ඒ කියන්නේ ළමයි, you are asked, let's say you are asked to make a glucose solution of 1 moles per cubic decimeter. ඒතරවා ඒ concentration එකෙන් හදනවා glucose solution එකක්. ඊට පස්සේ ඉවර වුණාට පස්සේ ඔයගලගේ teacher, let's say I come and measure. ඔයගලන් හදා තියෙන standard solution එකේ concentration එක හරිද කියලා මම ඇවිල්ලා measure කරනවා. මම මෙතන චුට්ටක් වෙනස් කරනවා. මේක 500 cubic. So at the end of, so I first ask you to make the standard solution and you do it alone. මෙයා මෙතන හැමෝම වෙන වෙනම හදනවා. At the end, I come and measure your concentration to check if you have correctly made the standard solution. Check කරලා බලද්දී ඇත්තම concentration එක is less than the actual concentration needed. The concentration of the standard solution is less than the concentration needed. And 1 moles per cubic decimeter now, then concentration, let's say 0.8, right? 0.8. So that is less than the concentration that is required. What could have been the possible errors? I'll give you 2 minutes to work this out. If there's no space in the note, you can write on the notebook. Less. Any answers you all got? නිකන් just possible errors ඔයගොල්ලෝ හිතන විදිහට ලියන්න. මොනවාද වෙලා ඇත්තේ? Now you know what is the equation for concentration. Concentration equals number of moles over volume. දැන් අපිට ඕනුනේ මෙච්චරක් හදන්න. හැබැයි concentration එක අඩුයිනේ. ඕන එකට වඩා අඩුයි. concentration එක අඩුයි කියන්නේ එක්ක number of moles වැඩි වෙලා. No, sorry. concentration එක අඩුයි කියන්නේ එක්ක number of moles අඩු වෙලා නැත්නම් volume එක වැඩි වෙලා. either number of moles අඩු වුණත් concentration එක අඩු වෙනවා. volume එක වැඩි වුණත් concentration එක අඩු වෙනවා. එහෙනම් yes. එකක් තමයි I'm getting correct answers in the chat box. Others also please tell me your answers. Weighing the solute less than the actual amount. Weighing the solute incorrectly කියලා විතරක් ලියන්න එපා. Weighing the solute incorrectly කියලා විතරක් ලියන්න එපා. මෙතන less than the concentration needed කියලා තියෙනවානේ. Less means එහෙනම් solute එක අඩුවෙන් තමයි measure කරලා තියෙන්නේ. එතකොට solute එක අඩුවෙන් measure කරාම number of moles අඩුයි, then concentration අඩු වෙනවා. Then I got another one. මෙතන volume එක වැඩි වෙලා නම් concentration එක again අඩු වෙනවානේ. volume එක වැඩි නම් concentration අඩු වෙනවා. ඒ කියන්නේ water is filled above the mark on the volumetric flask. අර volumetric flask එකේ තියෙන mark එකට වඩා වැඩිපුර. Water is filled above or more than the mark on the volumetric flask. ඒ කියන්නේ වතුර වැඩිනේ. එතකොට concentration එක අඩු වෙනවා. Then I have some other answers in the chat box. Other answers කියන්නේ මට අතන එකයි මේ මයුම්ද විතරයි answers දීලා තියෙනවා. What about others? Taking a volumetric tube less than 1000 milliliters. අපිට ඕනේ 500 cubic centimeters නේ. ඒතකොට 1000 එකක් කොහොමද ඕනේ? 500 cubic centimeter volumetric flask එකක් තමයි කොහොමද ඕනේ? Not mixing well, yeah, that's a good one. If you don't mix the solute well, concentration එක අඩුවෙන් තමයි record වෙන්නේ. Not mixing the solute well. Not mixing the glucose well. එතකොට අඩුවෙන් තමයි concentration එක පෙන්වන්නේ. Basically those, right? Is it clear to you, ළමයි? මට එක්කෙනයි මයුන් විතරයි answer කරේ. මොනවද අනිත් ලියුවද මේක? You can at least guess. I never expected you all to write 100% correct answers. I just wanted you all to do a little bit of thinking. But හිතලා බලන්න කොහොමද දෙන්නේ? නිකන් imagine කරලා බලන්න practically හිතලා බලන්න. That's what I wanted you all to do. හරි answer එක ආවත් නැතත් I would have liked if you all told me your answers. Is this clear? Give me a thumbs up if this is clear, everybody. Okay. Receive the calling thumbs up. Okay, all right. Another one. Same thing. You probably must have guessed it. Same thing. The only difference is question number 2. Now the concentration is more than the concentration needed. Another good one. Calling question එක තව හොඳ එකක් ආවා මට. Not washing the solute on the watch glass and the funnel. Very good. Watch glass එකේ තියෙන ටිකයි funnel එකේ තියෙන solute powder එක හරියට mix කරලා කියන්නේ හරියට wash bottle එකෙන් ඇතුළට transfer කරේ නැත්නම් again concentration එක අඩුවෙන් පෙන්නන්නේ. That's a very good one. Not transferring glucose on the watch glass and the funnel properly to the volumetric flask. Good one. Okay. So here in this particular case, what has happened is you are student Canova. You are asked to prepare 500 cubic centimeters of a glucose solution of 1 moles per cubic decimeter. Concentration is 1 moles per cubic decimeter. However, after making the standard solution, the concentration of the standard solution was now measured more than the concentration needed. Can one now then at the 1.5 wage. What are the possible errors? Lian Balan. Again, I'll give you 2 minutes. Quickly write. Okay, so yes, tell me your answers. I need others' answers as well. Huh? Nobody did? Okay, Mihaly, yes. Yes, Chenuli. Others? Yes, Sevindi. Yes, Mitna. Again, api concentration equals number of moles divided by volume. Yeah, impurities. Impurities are what more the less the but other two answers are correct. Yes. So concentration equals number of moles divided by volume. Now the concentration is more. Concentration වැඩි කියන්නේ එක්ක number of moles වැඩි. එහෙම නැත්නම් volume එක අඩුයි. ඔය දෙකෙන් එකක්නේ. number of moles වැඩි කියන්නේ මොකද්ද? ඒ කියන්නේ වැඩිපුර weigh කරලා. Weighing more solute than the required amount. එතකොට number of moles වැඩි, then the concentration will increase. Volume අඩු වෙන්න නම් filling water less than the mark on the volumetric flask. Right? So water අඩුයි කියන්නේ volume එක අඩුයි, volume අඩුයි කියන්නේ concentration වැඩි. Other than that, ඒ ටික තමයි. Impurities ගත්තහම impurities can either increase the concentration or decrease the concentration. For an example, now we are using glucose නේ. හිතන්න ඔය volumetric flask එකේ කලිනුත් glucose solution එකක් දාලා තිබ්බා කියලා. ඊපස්සේ ඒක වීසි කරා හැබැයි කන්නේ wash කරේ නැහැ. එතකොට ඒකේ ඉතුරු වෙච්ච glucose තිබ්බොත් එහෙම දැන් අලුතෙන් මේක හදද්දි there will be more glucose than the required amount. Then the concentration will be more. එතකොට ඒක අපිට හරියට එක definitive විදිහට ලියන්න බෑ because that is just something that we guess, right? ඒකින්ද ඒක අපිට ලියන්න බෑ, but these two are more than enough. Is it clear to all of you? Give me a thumbs up if it's clear. All right, then we are done with that, so we can move on to separation of compounds. Okay. Go to the next page. මේ questions දෙක මම මේ Q1 and Q2 questions දෙක ඇහුවේ මේ questions past papers වල තියෙන හින්දා. මම දන්නා past paper revision එකක් separately කරනවා, but it's better to prepare for past paper questions while we are learning, ne? That's why we talked about those as well. Okay, separation of compounds. Mechanics. So there are now in a mixture, whether it is a homogeneous mixture or a heterogeneous mixture, there are different components. So we should be able to separate these components. Can එකතු කළා mix කළා mixture එකක් හදනවා වගේම අනිත් පැත්තට we should be able to separate these components. So in this lesson we are learning 10 separating techniques. Separate කරන්න අපි techniques 10ක් ඉගෙන ගන්නවා. We are going to learn 10 separation techniques. Number 1 is mechanical separation. මෙතන මම ඔයාලට පොඩි homework එකක් දෙනවා. Let's first read. Mechanical separation methods are based on the difference of physical properties like density, particle size, particle shape, magnetic properties, and electric properties. මෙන්න මේ method එක මම ඔයාලට explain කරන්නම්, but as a homework, you all have to find this. Winnowing කියන්නේ මොකක්ද කියලා හොයන්න ඕනේ. Sieving කියන්නේ මොකක්ද? If you can even find pictures. Sifting කියන්නේ මොකක්ද? What is this? What is this? And what is this? මේ ටික හොයාගෙන ඉන්න ඕනේ. When I ask questions, you should be able to answer. Because මේවා හරිම these are like very simple things. ඒකින්ද it would be better if I ask you to search this first and then we discuss it later. Then you can get a good exposure. Pictures බලන්න පුළුවන්. මේක මෙහෙමද මේ picture එක මෙහෙමයි. Likewise, it's better that you find this first. They're very easy. You can just Google search and Google search. You can even use AI if you want to. But however way, I want you all to find these alone. Okay? මම චුට්ටක් mechanical separation ගැන කියන්නම්. The rest of it I will explain once you come to the next class with knowledge about all these methods. But for the moment, mechanical separation කියලා කියන්නේ අපි physical properties like density for an example. Density වැඩි. Now if you take a mixture, let's say there are two components. One component has a higher density, another component has a lower density. The density difference එක use කරලා අපිට ඒගොල්ලන්ව separate කරන්න පුළුවන්. For an example, density වැඩි එක්කෙනා හැමලෙම පල්ලෙහාට බහිනවා. Density අඩු එක්කෙනා උඩ පාවෙනවා. So ඒකෙන් අපිට density වැඩි එක්කෙනා separate කරගන්න පුළුවන්. We can use particle size. එක example එකක් විදිහට ගත්තොත් එimhe ඔයගොල්ලන් දන්නවා අර cakes එහෙම හදනකොට when you are making cakes like flour එහෙම ගන්නකොට අර පිටි හලන්නේ. ඇයි පිටි හලන්නේ? For the cake to have a smooth texture, it's very important that the flour is in fine powder. තුර නිකන් flour chunks වගේ තිබ්බොත් එහෙම that's not very good, right? ඒකින්ද මෙහෙම හලලා ඒවා chunks වලට කඩනවා. So එතකොට එතන particle size එක. අර පිටි හලන strainer එකේ ඇතුලෙන් යන්නේ particle size එක පොඩි powder particles විතරයි. ලොකු chunks වගේවා strainer එක උඩ ඉතුරු වෙනවා. Then particle shape, magnetic properties, electric properties, all of these we can use to separate components. That method we call it mechanical separation. Okay. So මෙන්න මේ ටිකට photos හරි මොන හරි හොයාගෙන එන්න. Photos හොයාගෙන ආවත් would be better. Okay. Then we'll discuss it next week. Second method. Vaporization or evaporation. Let's learn this now. Let's first read. Unnecessary components are vaporized by supplying heat to a mixture and the essential component is isolated. අපිට ඕන එක්කෙනා ඉතුරු කරලා ඕන නැති එක්කෙනා vaporize කරලා අයින් කරනවා. Okay. මේක දැන් මෙහෙම කොට ඔයගන්න තේරෙන්නේ නැහැ, so we will discuss this example. Purifying gold. දැන් ළමයි මේක මෙහෙමයි කරා. Impure gold කියන්නේ මොනවාද? Impure gold means gold plus impurities. Now, I have a question. Is mercury a metal, a non-metal, or a metalloid? Mercury. Mercury is it a metal, non-metal, or a metalloid? Is mercury a metal, non-metal, or a metalloid? Quick answer, please. Okay, Vindi. Others? Okay, Chinudi. Okay, Tinura. Okay, met me. Okay, Mayumdi. Okay, Miheli. So, I got some answers. Now, what is the correct answer? Is mercury on the activity series? Is mercury on the activity series? Activity series we discussed in the changes in matter lesson in grade 10. Is mercury on the activity series? Quickly tell me, lamai. මෙච්චර වෙලා ගන්න බෑ question එකක් අහද්දි. Okay. Others? කියන්න මම activity series එක. Quickly tell. අලුත් දේවල් ඉගෙන ගන්නදී පරණ දේවල් අමතක වෙනවා නම් අලුත් ඒවා ඉගෙනගෙන වැඩක් නැහැ. Okay? That is something that I very much believe in. ඕගලන් නිකන් load කළා ඔලුවට load කරගත්තට වැඩක් නැහැ පරණ ඒවා ටික අමතකයි නා. Then පරණ ඒවා අමතක වුණොත් ආයෙ මුලින්ම පාඩම් කරන්න වෙනවා ඒවා, right? So there are certain basic things like activity series, periodic table, මේවා නිකන් alphabet වගේ. Okay? So tell me, how does activity series start? Okay, potassium. Okay. Sodium. Okay. Calcium. Okay. Magnesium. aluminium. These are the most reactive. Then others. Zinc. Then after zinc, carbon activity series එකේ carbon is a non-metal. Activity series එක design කරලා තියෙන්නේ metals වලට. So carbon is definitely not in the activity series. Zinc after that, iron, yes, Fe. Then others, tin. Tin is Sn, yes. Then lead is Pb. ඊළඟට hydrogen ඉන්නවා. Hydrogen is the only non-metal present in the activity series. එයා ඉන්නේ නිකන් reference එකක් විදියට විතරයි. Okay? So hydrogen is just there. After that, copper. Then others, mercury. See, mercury is on the activity series, which means it's a metal. ඉතුරු ටිකත් කියන්න after mercury what comes? Not AU. Ag. Ag is silver. Silver වලට plus පස්සේ මොකක්ද දෙන්නේ? Not gold. Platinum. ඊළඟට මොකක්ද දැන් last එක? Gold. Potassium, sodium, calcium, magnesium, aluminium, the most reactive 5. Then zinc, iron, tin, lead, moderately reactive. Then hydrogen. And lastly, copper, mercury, silver, platinum, gold. The low reactive ones, right? So mercury is a metal. Okay? So there's a thing, Lamai, gold dissolves in mercury. Gold actually dissolves in mercury. Hontra dissolve in mercury vela. So mercury is a metal, no? Is mercury a solid or a liquid at room temperature? So mercury is a metal. Is it a solid or a liquid at room temperature? Room temperature. Yeah. Mataka tiyagana, we learned this in grade 10 third lesson. Mercury is the only metal that is a liquid at room temperature. So mercury is a liquid at room temperature. So මොකද වෙන්නේ දැන් මම ගන්නවා mercury solution mercury liquid එක. This is mercury. Now I have impure gold නේ impure gold කියන්නේ gold plus impurities. මං යාම මේකට දානවා. දැම්මම now gold dissolves in mercury නේ. Gold dissolves in mercury. Gold හොඳට දිය වෙනවා. So gold will nicely dissolve in the mercury. So this is mercury plus gold then. හැබැයි impurities mercury වල දිය වෙන්නේ නැහැ. So all the impurities will just stay suspended like this. මේ particles පාවි තියෙනවා. Why these impurities don't dissolve in mercury? Okay. Then what I do is I filter. Filter කරාම I can remove the impurities. එතකොට filter කරාම impurities ටික filter එකේ රැඳෙනවානේ. So I can remove the impurities by filtering. Can remove impurities. Then filter කරාට පස්සේ what do I have remaining? I have just gold plus mercury. They are dissolved in each other. I mean, gold is dissolved in mercury. Then matone mercury plus gold. No, I want pure gold. I don't want mercury. Then what I'm going to do is එතන තමයි මම මේ vaporization evaporation කියන technique එක use කරන්නේ. What do? I heat this. මං heat කරාම මොකද වෙන්නේ? the mercury is going to evaporate as a gas. Mercury is going to evaporate as a gas. එතකොට මොකක්ද ඉතුරු වෙන්නේ? Only the gold will remain. ඒකේ මට pure gold ගන්න පුළුවන්. So what happened was that impure gold තියෙනවා, that means gold plus impurities. Here gold dissolves in mercury, but impurities don't. මම මොකද කරන්නේ? මගේ impure gold එක mercury වලට දානවා. So the gold will dissolve in mercury well, but impurities don't dissolve. එතකොට ඒගොල්ලන් පාවි ඉන්නවා. Then what I do is I filter. Filter කරාම impurities ටික remove කරනවා. Now I have just gold plus mercury. But they are dissolved. So I have to find a way to remove the mercury because I only want gold. මම මොකද කරන්නේ? මෙයාව heat කරනවා. මෙතන තමයි vaporization use වෙන්නේ. මට ඕන නැත්තේ mercury. I don't want mercury. So I vaporize it and remove it. එකයි මෙතන කියන්නේ unnecessary components are vaporized and the essential component is isolated. Mercury evaporate karahama, what will remain is gold. From that I can get pure gold. So itana mama, here I used the technique vaporization or evaporation. Mama itana vaporization or evaporation kiyana technique eka use kara. See, that is a separating technique. I can also use the same technique to extract salt from seawater. You know, seawater wala salt uthiyana water thiyanawane. What I'm going to do is I'm going to heat it. Heat karahama water tika vaporize wala antimata salt tika ithuru wena. We will be learning about that in much more detail later. But just to give you an idea, and for now, seawater rat karahama, the water will evaporate and the salt will remain. That is how I get salt from seawater. Is this clear, Lamai? Okay. I would like if you can draw a sketch of this near your note. Note එක ඉඩ තියෙනවා නම් ඇඳ ගන්න. මොකද sometimes when you're studying, let's say හෙට term test එක අද පාඩම් කරනවා කියලා. ගොඩක් වෙලාවට එහෙමනේ ඔයගොල්ලන් පාඩම් කරන්නේ. එතකොට මුළු letters කියවනවට වඩා if you have something visually, that would be better for you to understand. And anyways, පස්සේ හරි note එක බලද්දී ඒක තේරුම් නැත්නම් ටගාලා diagram එක දිහා බලලා you can understand. Can you quickly make a sketch of this diagram? If you have space in the note, එතනම ඇඳ ගන්න. නැත්නම් you can draw it on your notebook. එහෙම නැත්නම් you can draw it on a sticky note and paste it. I have sent it in the group Pamodi. මේ note group එකේ වෙලා තියෙන්නේ. මේ grade 11 science group එක ඉන්නව නේද? Grade 11 කියන්නේ yeah, you are there. I anyways just sent it today also because Miheli was not there when I sent it to you before. So ඒගොල්ලන් අක්කොට මේක මම එවුවා නේද? නැද්ද විල්ලා? Yeah, it's there, no? Yeah. මම අද එවුවා ඒක. Okay. Quickly make a sketch of this. අපි තව එක ටෙක්නික් එකක් ඩිස්කස් කරලා ඉවර කරමු. So don't leave the class yet. එතකොට අපි next week mixtures ඉවරයි. I was actually planning to finish it today, but we also started the class a bit late. It's okay. Anyways, I think we are quite ahead, no? ඉස්කෝලේ මොනවා lessons කරන්නේ ළමයි දැන්? I think some of you have term tests. Some of you have sports meet. ඒකින්ද තාම වැඩි කරන්න නැතුව ඇති lessons. But I know term test එක ඉවර වෙච්ච හැටි ස්කූල් එක ටට ගාලා ඔක්කොම ටික කරයි. ඒකින්ද අපි චුට්ටක් ඉස්සරහින් ඉන්න එක හොඳයි. මොකද obviously school නම් you go to school all 5 days, all the 5 weekdays. But class it's just one day. I know we have 2.5 hours, but sometimes it's not enough to keep it balanced. ඒකින්ද අපි හැමලෙම චුට්ටක් ඉස්සරහින් ඉන්න එක හොඳයි. First lesson and second lesson. Any school doing the third lesson yet? මෙතනගේ third school third lesson එක. Anyone else? Thinura, in next week you're starting mixtures. Okay. After mixtures, actually, we are going to do light geometrical optics. If you are digga padamak and there's a lot of practicing to do. Make it draw karakana. Don't leave the meeting, na? Yeah. One more minute. Okay, line. Shall we move on? Done? අපි filtration එක කතා කරලා ඉවර කරමු. Give me a thumbs up if you have finished drawing this. All right. Okay, so next method, next separation technique, filtration. We can separate the components that remain suspended in a liquid without going into the solution in a mixture using filtration. A filter is used. This is pretty simple. දැන් අපි හිතනවා තේ හදනවා කියලා. ගොඩක් වෙලාවට now some of you might be using tea bags. Tea bags use කරනවා නම් ඒක එච්චර එන්නේ නැහැ. Tea bags වලත් අර tea bag එක හදලා තියෙන filter එකකේ. But let's say තේ කොළ use කරලා තේ හදනවා කියලා. එතකොට තේ කොළ උණු වතුරත් එක දාලා mix කරලා whatever and then you filter it නේ. Filter කරාම the tea water only will filter and fall onto the cup. The tea leaves, the boiled tea leaves will stay in the filter. ඒ කියන්නේ අර tea leaves එක නැත්තම් පාවෙන්න තියෙන්නේ. නැත්තම් if you take like let's say making tea මෙතන අර ටී පවුඩර් ටික මෙහෙම පාවි තියෙනවා. තේ වතුර ටිකක් තියෙනවා. So මේක ෆිල්ටර් කරනවානේ. ෆිල්ටර් කරාම තේ කුල ටික ෆිල්ටර් එකේ රැඳෙනවා. තේ වතුර ටික ෆිල්ටර් වෙලා වැටෙනවා. ඒක තමයි අපි අරගෙන මිල්ක් දාලා බොන්නේ. Right? So that is one example. ඒ වගේ ලැබ් එකේ තියෙනවා ෆිල්ටර් papers. Right? ෆිල්ටර් papers කියලා જાතියක් තියෙනවා. නිකන් රවුන්ඩ් කොලයක් වගේ. ඒ කොලේ මෙහෙම නවල අපිට ෆිල්ටර් එකක් විදිහට පාවිච්චි කරන්න පුළුවන්. In water purifying plants, we have sand filters. ඔය ලොකු water purify කරන ලොකු setup systems වල there are like different layers of filters. charcoal වලින් layer එකක් තියෙනවා. ඊට පස්සේ තව like වෙනම මොනවද board what do you call it? board මම මතක නැහැ ඒකේ නම හරියටම but there's like this like a membrane sort of එම filter එකක් තියෙනවා. ඊට පස්සේ I sand layer එකක් තියෙනවා. So that is also a filter. Impurities එහෙම රඳවලා the clean water will be filtered. We are going to talk about an example here. I have a mixture of water, salt and soil. Right? Mixture of water, salt and soil. If you take water plus soil, salt, is it a homogeneous mixture or a heterogeneous mixture? Is it a homogeneous mixture or a heterogeneous mixture? Water plus salt. Homogeneous. What about water plus soil? What about water plus soil? Heterogeneous. Salt නම් හොඳට දිය වෙනවා but soil වල particles දිය වෙන්නේ නැතුව තියෙනවානේ. So that is a heterogeneous mixture. So මෙතන water එකක් තියෙනවා, salt උත් තියෙනවා, soil උත් තියෙනවා. What do I do? I have this glass funnel. Funnel එකක් තියලා මෙන්න පොඩි flask එකක් තියෙනවා. මේකට තමයි මම filter කරලා දාන්නේ. මම කියවනේ lab එකේ there are something called filter papers. මෙහෙම නවල අපිට filter එකක් විතර use කරන්න පුළුවන්. මේ funnel එකට මෙන්න මෙහෙම filter paper එකක් දාලා තියෙනවා. funnel එකට filter paper එකක් දාලා. මෙහෙම glass rod එකක් මෙහෙම තියලා තියෙන ළමයි නැත්තම් filter paper එක මෙහෙම උඩ යනවනේ. ඒකින්ද ඒක හරියට hold කරන් තමයි glass rod එක තියලා තියෙන්නේ. Excuse me. Then what we do is that we are going to pour this mixture. මේක pour කරනවා. pour කරාම මොකද වෙන්නේ? Now water and salt are homogeneous. එතකොට salt water එක හොඳට mix වෙලානේ ඉන්නේ. එහෙනම් filter වෙද්දී waterයි saltුයි දෙකම filter වෙලා flask එකට වැටෙනවා. Salt. But soil is not mixing in water well. So soil ටික මෙන්න මෙතන ඉතුරු වෙනවා. Soil මෙතන ඉතුරු වෙනවා. Why water and soil heterogeneous නේ? ඒගොල්ලෝ mix වෙන්නේ නැහැ. So soil ටික ඉතුරු වෙලා filter එකේ water and salt filter වෙලා පල්ලෙහාට වැටෙනවා. So what is getting filtered? We call it the filtrate. What remains on the filter, we call it the residue. මෙතන තියෙනවා when filtering the component that gets filtered is called the filtrate and the substance left in the filter is called the residue. Is it clear, Lamai? Give me a thumbs up, please. Others? Tinura, Desindu? Okay. With that, we will end today's class, Lamai. As you all know, today is the last day of the month. So next week, we will be meeting on 7th of February. And next week, we'll be finishing mixtures and we start the light lesson. Light එකට යා ලොකු පාඩමක් නේ ඉවර කරගෙන අපි waves වලට යමු. Waves එච්චර ලොකුයි but there's a lot of theory, so I will anyways be giving you a PDF. ඒට කියවුණාට පස්සේ තමයි දිගම පාඩමක් තියෙන biology, right? So අපිට අටක් ගාලා ඒ ටික කරමු. Always remember that finishing the syllabus in July වගේ තමයි අපේ end goal එක, right? So ඒක ඔළුවේ තියාගෙන අපි කරගෙන යමු. Yeah, that's all I have to say. I will send the whiteboard note of today's class to the group as well. before we end the class, do y'all have any questions, concerns, any doubts, or is everything clear? If everything is clear, give me a thumbs up. Okay. Desindu Tinura met me. All right. Then Lamai, see you next week on 7th of February. Printouts nathi printouts arangena Miheli and wait, we have a question. Omina Lamai, why can't we wash all the water with salt to the flask instead of 2 parts? ඒ කියන්නේ අපි ෆිල්ටර් එකක් සෙට් කරලානේ තියෙන්නේ මෙතන. It's okay Mayundi. Here we have a filter no. Filter එකෙන් filter වෙන්නේ water එකත් එක්ක dissolve වෙලා ඉන්න කෙනා විතරයි. Since salt is dissolved in water, that gets filtered. But soil is not dissolved, soil particles පාවි ඉන්නේ. In the standard solution. Why can't we wash all the water with salt to the flask instead of you mean met me එකපාර water mark එකටම fill කරලා mix කරාම හරි කියන එකද? I mean අපි මුලින්ම කරන්නේ 2/3 fill කරලා and then shake කරලා ඊට පස්සේ ඉතුරු ටික දාලා ආයි fill කරන එකනේ. දෙපාරක් fill කරන එක නේද ඔයා කියන්නේ? Right. Good question. මම එකත් clarify කරලා ඉන්නා. අනිත් අයලත් අනිවාර්යයෙන් මේ ප්‍රශ්නේ එන්නේ නැති but not all of you speak no. Here අපි එකපාර salt එක නම මෙහෙම salt එක දාලා so this is all the salt that we transfer from the watch glass and then අපි එකපාරට mark එක ළඟට වෙනකම වතුර පිරෙවුවා. පුරෝල අපි shake කරද්දී we have a small doubt will all the salt dissolve. අපි මෙතන කරන්න හදන්නේ මෙතන final volume එක ගනිද්දී. ඒ කියන්නේ දැන් හිතන්න now I put salt here නේ. ඒතර salt මම ඔයගලන්ට කියලා තියෙනවා සාමාන්‍ය solvent එකේ volume එක තමයි අපි final volume එක විදිහට ගන්නෙ. We don't really consider the volume of the solute much because solutes don't have a significant volume. හැබැයි පොඩි හරි contribution එකක් තියෙන්න පුළුවන් නේ. මෙතන salt එක මෙහෙම particles විදිහට තියෙද්දි ඒගොල්ලන්ටත් already volume එකක් යනවා. ඒතර ඒ ටිකත් එක්ක මම මෙතන volume එක measure කරලා මෙන්න මෙහෙම ගන්නවා. අරගෙන ඊට පස්සේ salt එක ඔක්කොම හොඳට දියුණාට පස්සේ this would go down like this. එහෙම වෙන්න පුළුවන්. චුට්ටක් අඩු වෙන්න පුළුවන්. සමහර ලාවට එහෙම වෙන instances ඕන තරම් තියෙනවා. ඇයි ඉස්සලා තියෙන salt එක particles විදිහටනේ. particles විදිහට තියෙද්දි මම උඩටම වතුර පිරෙවුවා. පුරවලා then I mix it well then mix කරාම ඔක්කොම dissolve වෙනවනේ. dissolve වුණාම the water level could go down a bit. That is one of the reasons why I first fill 2/3 then mix it well mix වුණාම ඔක්කොම salt එක mix වෙලා then only I fill it up to the calibration mark. එක. අනිත් එක තමයි සාමාන්‍ය salt පොඩ්ඩක් දාලා වතුර ගොඩක් දැම්මට කියන්නේ salt එකක් මෙහෙම දාලා වතුර උඩටම දැම්මට පස්සේ mix කරන්න ටිකක් අමාරුයි. කියන්නේ හොඳට mix කරන්න අමාරුයි. So for an example අපි හිතමු ලොකු pot එකක් තියෙනවා කියලා කලයක්. One second. One second ළමයි. So සාමාන්‍යයෙන් ළමයි salt let's say 100 grams අරගෙන අපි එකක් දානවා normal bottle එකකට දානවා then it's easy to mix right තව එකක් අපි දානවා ලොකු pot එකකට. ඒතර water amount එක ගොඩක් වැඩි. ඒතර ලොකු water amount එකක dissolve කරනවට වඩා පොඩි water amount එකක dissolve කරලා later water add කරාම it will be more consistent. හොඳට dissolve වෙනවා එතකොට. ඒ කියන්නේ අපි මෙතන full වතුර fill කියන්නේ භාගයක් වතුර fill කරලා mix කරලා full වතුර කියන්නේ how do you say this? So it's partially filled. 2/3 I fill it and then I mix it well. I ensure that all the salt is mixed and then I fill it up to the mark. එහෙම නැතුව මෙතනටම කියන්නේ කට ළඟටම නේ but kind of near the mouth නේ. එතනටම water fill කරලා mix කරන්න ගියාම it's a little bit difficult to mix. Do you understand what I'm saying with me? Is it clear? Right. So those are the two reasons. එකක් තමයි volume එක හැට මට වෙනස් වෙන්න පුළුවන්. අනිත් එක තමයි mix කරද්දී there could be a difficulty if we take a larger volume of water. But පොඩි volume එකක mix කරන්න ලේසි. ඇත්තටම උඩට වතුර පුරලා තියදී අපිට ගොඩක් හොඳට mix කරන්න අමාරුයි. That's why. That is a good question. ඒකයි අර තව ඇහුවේ කෙලින්ම wash glass එකකින් මෙහෙම දාන්න බැරිද? අයි wash bottle එකකින් wash කර කර දාන්න කියලා. So they are both very good practical questions. So ඒක කරද්දී තමයි ඇත්තටම ඒකේ like you get the hands-on experience. But since we can't do it, it seems like you guys have imagined it well. That's why you're getting questions like that. Anyways, okay, then see you next week, Lamai, and have a great week. Good night.